Yes, another day, another compromise in the Lord's year 2026. Talking about the light LLM hack today. It's a wonderfully tragic story about a
Hello everyone.
Hello.
Hi.
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 Hello, Mr. Bala. Hi,
Hi
Sai. Hi,
Amrita.
Kirti.
Hi Kirti.
Hi, Sridhar. Hi,
Hi,
Kirti. Hi,
hi all.
Amrita.
So, Bala Sairam is the trainer,
Okay.
and yeah, he'll be starting a T1 cloud from 1st April.
1st April. I think may I know which module he's going to take in from. I mean which topic he's
Uh,
going to begin it.
Topics, sure, I'm telling you. He'll go with cyber security,
Mm-hmm.
then platform engineering,
Okay.
then SRE. SRE. These
Yes,
all
sir.
the topics he will be teaching. Yeah.
Okay. Okay. These three only, correct?
Yes.
Yeah, yeah, yeah.
Okay. Mm-hmm. Then okay, who is going to take in care of this okay, data security and all these things? He's only going to take it, that correct?
Data security, just a minute. Huh? Cloud platform, everything. My trainer Akshiv is completing actually. It is finishing till 28th March.
Okay.
Yeah. So my current trainer Akshiv actually is already well versed with all of the topics, but he is
No,
not available since
no, that
coming Monday.
doesn't matter. When he's
Uh-huh.
going to begin with that, April 1st, correct?
Yeah, yeah, April 1st.
April 1st is a security, cloud security fundamentals, I guess.
Mm.
Yeah,
Correct. Okay.
yeah. Yeah.
Okay.
Okay.
Shall I show the screen,
No,
Bala, if you need?
I have a data, no issue. No,
Okay,
no. That's what I'm
okay,
referring
okay.
back. Give me a moment, okay, because
Okay,
it's a ad hoc request for me. That's what I'm re-verifying.
okay, okay, understood.
Okay, Sai. Okay, could you please turn on your camera?
Yeah. Hi.
Hey, hi. Okay. Could you please, okay, could you please, okay, brief about your technical expertise?
Okay. So myself, Sairam. I'm basically training for the past 7+ years. I have trained engineering, BSc, MSc students across Bangalore and in Karnataka, and as well as out of state, Gujarat and Maharashtra. So
Okay.
and Chennai, I'm in Tamil Nadu as well. So I have taken about 40 plus batches till now, in topics ranging from Java, C, C++, Python, uh, cloud, and cyber security.
Okay.
Uh, so I have taken classes for various colleges like St. John's Christ, Presidency, KLE, Don Bosco. Um, yeah, so these are the few of the colleges I have worked with. Uh, and if I'm sure, I'm supposed to take cloud security, platform engineering, and SRE, I think, if I'm not wrong.
Okay.
So these are the topics I am supposed to cover in Haldia. Uh, so that's what I'm planning to cover. So basically, we are asked to cover both the AWS and Azure, if I'm not
Mm-hmm.
wrong. Uh, so are we going to like what I was planning to do is I was thinking of having a local setup, like having a replica setup of AWS or Azure on the local systems, then planning the validating in locally first, then trying to deploy it on AWS or Azure. So I hope I have the freedom to do that, or should I just stick with AWS or Azure?
Okay, that part I will come to a bit later. Okay, so now I would like to understand from that. Okay, so what is your standpoint with the SRE?
Mm.
How will you? What is your approach to make beginners to understand what is SRE like that?
Okay. Okay. How I will explain SRE is I'll explain to them like any product that you are deploying, you need
Mhm.
to assume that it's going to fail at one point or the next. So you need to take into considerations what are the parameters that your organization or whatever your client is, that they are expecting what kind of when the app, if suppose it crashes, so when is it supposed to come back up, when are they expecting the service to turn back on, or they're expecting no downtime. That kind of consideration I will explain, that client will have such requirements. Let's suppose if it is a fintech or a hospital, they want 99.99% uptime, they never want their service to ever go down. So but if it is something like a e-commerce site, one part of it could not be working and it is fine, they can manage that. But that depends on the client, so they will have to understand the client's requirement first, or what the organization they're working for, their requirement first, and they have to design accordingly, like how they are going to approach it. So how much uptime you want, how much backups you want, how much storage it's going to take, those things you need to plan, and accordingly you have to automate all those things, because or else you have to monitor everything if you're not going for automating. But automating is what I think is advisable, because monitoring those logs will be quite difficult to do. So that is how I will explain how why you want SRE to be there.
Okay. Okay. So let me put you one scenario over here. Okay, so there is a mobile application. Okay, so nowadays all the mobile application coming as a patch update. Okay, so those kind of scenario, how will you manage with our, I mean, our application development life cycle?
So I will first explain the various types of deployment strategies. We have blue, green, we have canary deployment strategies. So based on that, such strategies, you are going to uh, test. You can have shadow deployment as well. So based on your user base and the trust they have in you as a company, if you can have a public announcement that you're going to have a new version and you're going to test it on them, and check your backends if they are working properly. If it is a shadow deployment, you don't need to announce it to them or anything. So you can design it such that your user base is either informed, they could be in the dark. But it depends how you want the product. If it is a very crucial application, let's suppose it is like something like IRCTC or something, a banking application, or like a IRCTC application. So you don't want to experiment too much on it. So you should do go ahead with a blue green deployment strategy over there, where if suppose there is any problem with the green, that is the new version, you should be able to go back to your previous deployment. So that's how I will explain, like why you want to have different kind of deployment strategies, and that how you're going to choose which deployment strategy you're going to implement based on what the requirement of the application is going to be. So if it is not a non-crucial application, so it can the deployment can happen differently.
If suppose if I have a microservices based application, which my part of the application is going to develop with multiple services or multiple patch of services, in the sense, which approach, okay, would you suggest to, okay, follow up with that?
So we will generally go with normal. We will just update our pods, few pods will update, and over time we will further service. For each service we have let's suppose n number of pods, we are going to incrementally increase the uh, updates on the pods. If any pod fails, we are going to roll back the update. So that's what I will suggest they take on if they are going for microservice architecture and they want to update their app. So
Mm-hmm.
that's what I am going to suggest they do.
Okay, for example, I want to develop one mobile application. That mobile application is which is going to be initial with a one phase with a minimal update. Then okay, on time being okay, I want to release the update. Okay, for that, okay, what is your approach? Okay, how would you make okay reduce the downtime of the application? Okay, so okay, and also I want to have a zero downtime for my application during the update and everything. So how would you configure these kind of models?
Mm. So basically, I will have two parallel uh, uh, two parallel versions, the old version and the new version, running on two different clusters, and I will have them working in my dev environment. I'll test it out how much I can test it. Then I will slowly release it using a canary deployment strategy, and see if there is like good response. If there is good response, there is no crashes or there is no errors, no bugs, I am going to continue the deployment until I have covered my entire user base. So for a small update I can do this strategy. So if it is a major update, I can't use this strategy. I would opt for a blue green strategy over there. So that's how I am going to do it. But what was the other question you asked? I forgot. Can you please repeat the question?
No, that my question is simple. Okay, you already answered that. Okay, I want to have a zero downtime. My
Zero
major
downtime.
expert is I don't want to have a zero downtime.
Okay, so
During
then
my update, my application should not go in the down mode. And also because of the new update, the existing feature should not be disturbed. So within the case, what are the factors we should follow with that?
mm, so you have to take into account which are the microservices you are updating right now. If it is because it is a minor update, it won't be all the microservices. So you just focus on those pods, and you can slowly upgrade them and check the pods health. You will check the health of the pods, and you will restart the pods if they are failing. uh, that's how you're going to do it.
Okay. For deployment, okay, for deployment managing these applications, okay, what is the role for Kubernetes and what is the role for Docker?
Okay. So you will opt for Docker or Kubernetes based on your architecture, how you have designed, how the developers have designed the application. Let's suppose it's a monolithic architecture design. You can opt for Docker. You can opt for Docker containerization, and you can push its image to Docker Hub, and you can pull it, and you can run it on your containers on the cloud. But if you are having a microservice architecture in your application, it is you can do Docker container. You obviously need to do containerization, but you cannot manually orchestrate the.
Could you please explain me what is the purpose of Docker container?
Okay, so I will explain Docker containers like this. Let's suppose you have a working code on your computer, and
Okay,
you want to ship that to the client. So what you
okay,
will notice that if you just copy the files without checking your operating system, without checking what your underlying hardware is. Let's suppose you had a AMD processor, or you had a Windows operating system, and your client has a Intel CPU, and he has a Linux operating system. You just can't pick up the software from entire file, build it up the artifact, and just expect it to be running properly on your client's machine or the client server. So to overcome this, Docker containerization came up. They expanded on the idea of virtualization, because virtualization already tried to solve this by trying to run a container operating system in which you are running your application and then shipping the entire container image, I mean the operating system, whatever setup was, as a script to your client, and then you're going to run the script over there with git clone etc commands, and you're going to build the entire environment there. So that was the earlier approach. Then docker containers, I mean docker came up with a new suggestion, because this virtualization was a kind of resource intensive, it was taking more resources. They thought, why not just limit the uh, virtual container or the virtual operating system, why not just limit it to the application and its dependencies? Why not do that and package it as a container? So this container, if it is running on your machine, you can just ship the, I mean you can just upload the image to the container image to the Docker Hub, and then you can have any person around the world download it into any other operating system, any configuration on your phone, anything, and they can have it running there. They just need to have the Docker runtime running on their device. So that's where containers came about, and how we are currently using containers, and why we need to use containers.
Mhm. Okay. Then Kubernetes where come into the picture here?
So Kubernetes comes into picture when there is not just one container you are working with. If you suppose, let's say you are working with micro service architecture, you don't have just one container you want to run. You will have at least 10, 15, maybe it could be more than that. So you have 10 or 15 containers you need to start up at the same time. Then you have something known as a Docker Swarm, I think. You could have used that. That will work up till a small size project. But Kubernetes comes into picture when you want, excuse me. So Kubernetes comes into picture when you have multiple number of containers, and you want to ensure that these containers are not just they're up all the time and they are not getting down. If one you can monitor the system, I mean CPU usage and the memory usage of each container, and based on those metrics you can decide if you want more number of containers for a single service, and you're going to whatever the uh, request you get, whatever request you get, you're going to basically use Kubernetes to traffic it to the appropriate pod for the specific service whichever you are using. So these things you had to do it manually. If you are going to do it using Docker alone, you have to write your own scripts, you have to monitor everything manually. You could have maybe gone with some scripting and you might be able to do it, but it is more difficult, it is more manual work. But if you go with Kubernetes, it will you don't need to think of all these things. You can just try to kill a pod. If there is you have multiple pods, you have multiple containers per service activated, like you selected it, like 3 or 5 pods per service, like containers per service. What will happen if you try to kill a pod, or to simulate that the pod is down? What will happen? It will automatically restart the pod, or recreate the restart the container, and it will be up in no time. So that's something Kubernetes does on its own. You don't need to if you were on Docker, you would have had to do it through scripting or something, or you would have to check your logs. You have to have some clauses which when they trigger, you would have to do it manually. So that's something that complexity had been reduced because of Kubernetes. So that's where you are going to use Kubernetes.
Okay. Here, what is the use of the Terraform then?
So Terraform is basically used to allocate your resources on your cloud. So whatever
Mm-hmm.
resources you are having, let's suppose on your local instance, if once you for validating you have run Kubernetes cluster with one node on your uh, uh, local machine, and you check all the resources how much it is taking at its peak usage. Just log it and use that as reference, and create a Terraform script such that it will allocate sufficient. Maybe you take a factor of safety. Let's suppose two factor of safety. Let's just double the amount of CPU and the double the amount of memory per container per service for the Kubernetes, and you're going to write that in your Terraform for it to automate the allocation of resources automatically. You don't need to do that manually again. So that's where Terraform comes into picture.
Okay. So, okay, you are coming with a okay, good idea and good approach. Okay, but I have a few more questions with you. If suppose, okay, you are having, okay, for this understanding these technology or this SRE and all these things, the people should have the ample amount of development and application background knowledge with that.
Mm.
Okay. If suppose the batch, I mean the training or the folks which you are going to handle are taking a training with them, so those people doesn't have such a sufficient knowledge in the sense, okay, so how would you make them to engage these participant, or how would you make them to understand these concepts over there? What is your thought process over here?
Okay, so I will first start up with why we need cloud first. So I will explain what used to happen before cloud came into picture. How people like this will basically be focused on web applications and web application. I'll focus on web application because that is easier to explain. I feel. I will explain them how like internet came into picture, like why we are using lot of services online now rather than going for before we would have standard binaries on your like you would have standalone binaries on your operating system like for a specific operating system. So how browsers came about and they democratized web applications, and how these you are not zoned in on a particular operating system, and you could if you are able to launch your application on the web, how you will reach a larger audience, how companies started transitioning into web applications, and now it is a norm for everyone to launch a website for any of the products. So that's where I will start. Then I will tell them how they used to have their own internal IT teams, how they used to have their own infrastructure. They used to purchase these server grade computers, their networking devices, how they will regularly update them, maintain them. They used to do all these charges. They used to have such expenses because of this maintaining these servers on their own, and how Amazon came up with the idea of why not rent compute. So Amazon was the first one to come up with the idea of renting compute out, and how cloud came into picture. So that's where I will start, and then I will explain to them the different kinds of architectures. Basic, I will just explain the three-tier architecture of the web application, like how you have a client, how you have a backend, and how you have a database. And I will explain how you want to calculate the load. If you have concurrent users, how many concurrent users equal to how much RAM usage, how much CPU utilization, and how you're going to track that, and how you're going to map it out in your cloud infrastructure. So how before they were in AWS, they will opt for drop-in migration, right? So they will just pick the live server that was working on their uh, setup, on their local setup, and they are just going to take the entire thing, and they're going to just replicate it inside a virtual machine virtual machine instance. And I'm going to explain that and why we moved from that to containers. What is the advantage? So why we did that, because let's suppose the container like the live server which you had locally, the company, whichever company I'm taking as example, that had a local server. Let's suppose it was 128 GB RAM and 30 or 48 cores CPU. To replicate the same thing in cloud for EC2 instance, you would have to pay maybe about $10 or something per hour. So that is not feasible for you. So then you will look for other options. So that's where innovation happened, and Docker containers came about, and how they thought, why are we wasting resources on running the entire operating system? Why not reduce the costs? And that's how slowly all these things came into picture, and how larger scale applications came into picture, like Netflix, or like I will take Netflix as an example. That's a good example. Why? Because it used to be a monolithic architecture in 2009 or something, until 2016. I think slowly they were transitioning into microservice architecture, and how it benefited them. I will pick up the whatever the analytics are there, and I will show them how it helped them, and why they transition to this microservice architecture, how it helped them to reduce their costs, why companies are slowly moving to cloud, why we are like in India, generally startups do not have the capital to invest in the server grade equipment. They won't be able to purchase the server grade CPUs, motherboards, whatever. So they won't have a space to host that. They won't be able to, let's suppose if they could build a commercial PC in 1 or 2 lakhs, for the same equivalent grade server equipment, they would have to pay like 10 lakh rupees. So for a startup, it doesn't make sense to upfront 10 lakh rupees. So they will opt for some other option. So the alternative is this cloud, how the cloud is offering. So what cloud says, you pay as much as you use. So what these startups will think, yeah, that's a very good idea. They don't need to think about if they have some IT skills, they will opt for EC2 instance or something. So they know how to maintain their own operating system, manage their operating system. They will opt for that. If they don't know how to manage that, they're going to go for Elasticbean or something, so that they will just think about the application. They don't need to think about maintaining the or scaling the application. They don't need to think about. They just keep some uh, like. Uh, billing targets, so that whenever those targets hit, they will get a notification, and they can decide if they want to go proceed with the deployment of the application, if they want to pause it. Depends on how they are going to do it. So that's how I will explain the whole like journey, how we are currently standing here, and what is the path future. So in the future, we are expecting more cloud migrations happening. So a lot more migration is going to happen, and how even like uh, IoT is coming into Kubernetes now. So how they are using K3s for IoT devices, and I thought K3s could be used because it is a less simpler version of Kubernetes and less resource intensive. So we can try to deploy it on their local devices. They will try to do it themselves and learn. So that's how I am thinking. They have to actually, I will try to get a repository of the same application which is monolithic in structure, then the same application as a microservice, and I will show them how to deploy both, and I will explain how this is being deployed, how much resources it is using, why we are doing this Kubernetes, and how where it makes sense to go with Kubernetes and where it doesn't make sense. Those are the things I am planning to teach. That's how I am planning to teach. Hello.
Hello,
Yeah,
Bala.
yeah. I'm listening that. Okay, sorry, I was in the mute. Okay, so if suppose if a fresher is listening to, okay, I mean, doesn't know about the web application. Okay, if suppose, okay, they are hitting a URL. Okay, www dot okay cnn.com or ipl.com something. If they're hitting in, what is the process was happening? What is your approach to make yourself to understand the business?
Make uh,
How will you make them to understand about this business scenario?
okay. So I will take a scenario where they are asked to log into a website. Let's suppose I will ask them to go to Amazon.com or something. Then I will ask them what are the steps they did. They will obviously tell me that they opened the browser, they typed the uh, URL into the URL bar, and they clicked enter, and they will see the page loading. So I'll ask them to open developer tools by pressing F12, and I will ask them to reload the page, and they can see how it is calling various servers, how the status codes are updating, like how this DNS DNS, like your name is registered in the DNS, and how it will be mapped to a public IP of your server which is running, and how this traffic is routed through there, and how it will be going to your application. Those things you can see through F12. If you just press F12 and you click on any element, you can see what is happening in the network tab. So you can see what is happening in the network tab. You will see there is a fetch request, there is a the status codes, all these things. I can explain to them what are these status codes. 200 means success, you get 400 for a bad user request, you get 500 for internal service error. All these things I can explain and tell them that this is what is happening when I'm talking about a web application. So they can, if they understand web application well, they can just mirror the understanding onto mobile applications as well. So that's how I think I should explain. If they are unable to understand, maybe I will draw, maybe show them some PowerPoint presentations, or show them by maybe a DNS like URL name, and maybe map it to something and show how it is working. Maybe show them how to set it up so that they can experience it themselves. So doing it themselves will be better, I feel. Explanation takes it till a level, but they have to do it on their own to understand what is happening. That's how I think we should teach them. Yes.
Uh, Bala, I guess you're on mute again.
Yes, yes. Sorry, I was in the another phone call. That's why. Okay,
Okay.
Sairam. Okay, little bit. Okay, don't mistake me. I have little bit suggestions to you. So you are taking with a detail and a brief examples to the all the topics. Okay, but before my thought process, okay, you are making me to understand. That is a very good. I need to thankful for you. But meanwhile, when we are taking to the participant and what is their mindset and what is their background, it is much important. Okay. For the absolute beginners or those who are in the college mindset, we cannot able to make this kind of technical elaboration in that. Okay. For them, what is the way we need to understand their pulses and understand their background knowledge. Based on that, we have to dive into the examples. Okay. You are giving the right scenario. This is what happening. DNS server. The first of all, the people we should check with them whether they have the knowledge of the DNS or not. Then we can make them with that. Otherwise, we can go with some general real world example. These are the suggestion my suggestion to handle the freshers. Okay, because you are not beginning with a first day training for these folks. Okay, you are going to continue somebody who's already completed with that batch. Okay, so here you can't expect the perfections what you are going to set up with those. Okay, some kind of gaps will be there, some kind of okay background knowledge, maybe lack of, they may be lack of some background knowledge on that. So these are the area I'm request you to check. According to that, you can take a decision. Okay. So apart from this suggestion, I'm okay with everything. Okay. We will get back to you soon. Okay. Thank you so much, Sairam. And thank you,
Thank you.
Amruta, and
Thanks,
thank you,
Bala.
Kirti, for
Thank you,
arranging
Bala,
this.
Kirti, and
Thank you.
Amruta.
Thanks, Sairam.
Thank
Thank you
Okay.
all.
Thanks.
Thank
Bye.
you.